and I'm from Telangana, Hyderabad. Presently, I'm working in Bangalore Metallurgicals. I've started my career in 2011. Since from 8 years, I'm working in foundry in quality department. I have good hands-on experience on NDT, post and pre-production quality, and lab activities and paint shop activities. And coming to quality, what is quality? Looking for quality is nothing but looking for something, some defects or flaws. People have found many definitions for quality. Some of few. For a inspector, meeting the customer requirement is a quality. And the person who want to buy a product, for him degree of excellence is a quality. The end of the user who is using the product fit for use, for him that is a quality. And for the calibration departments or for management departments, conformance for the requirement is the quality. What is the goal of quality? Quality is nothing but quality is not a fine-tuning process at final stage before dispatch. It should be inbuilt in every stage of inspections, starting from pattern shop to dispatch. बोले तो हर एक process में procedure, we have a first we'll check the pattern inspection, visual pattern कैसा है क्या देखते हैं. कुछ प्रॉब्लम्स है तो वो अल्टीमेटली उसको पैटर्न शॉप को दिखा के कुछ वो प्रॉब्लम है तो सॉल्व करके नेक्स्ट मोल्ड शॉप को देते हैं. ऐसा पैटर्न शॉप में, मोल्डिंग में, कोर मेकिंग में, क्लोजिंग में हर एक पैरामीटर्स फॉलो करना है, यही क्वालिटी है. देन ओनली यू विल गेट द अल्टीमेट प्रोडक्ट इन द final inspection. Or else if you are not following all these things, there is no use, there is no point at all. फाइनल में आने के बाद कास्टिंग ऐसा प्रॉब्लम है, वो प्रॉब्लम है, ऐसा होता है. इसीलिए क्वालिटी शुड बी इन बिल्ड प्रोसेस एंड इट हैज टू बी फॉलोड इन एवरी प्रोसेस. राइट जी. नेक्स्ट. Now coming to quality assurance and quality control. Quality assurance comes under process oriented. Quality assurance बोले तो वो process oriented है. जो product बाहर आने के पहले वो कैसा defect free रहना है, वो defect free casting आना बोले तो क्या क्या हम precautions लेना है, क्या क्या देखना है, वो क्वालिटी एश्योरेंस का काम है. The main aim of QA is to detect the flaws and correct them before producing the casting, defect-free casting. This is the role of quality assurance. When it comes under quality control, it is a post-production quality. Post-production, एक बार casting बाहर आने के बाद हम dispatch करने के लिए हम क्या क्या करना है, वो तो क्वालिटी कंट्रोल का अंडर आता है. The main aim of QC is to check and test the product as per the customer requirement, and results are reported for further analysis. Next slide. Right. Why quality is important? Quality is important in any industry, because if any deviation missed in the final check, then all the process calls for failure. If कुछ प्रॉब्लम होता है हमारा प्रोडक्ट में, कोई भी बोले तो वो प्रॉब्लम किसी को भी देख नहीं पाएगा, कोई डायमेंशन का इश्यू होगा, नहीं तो एक सस्पेंशन पैड एक्सेस आया, तब एक क्वालिटी पर्सन चेक नहीं किया, वो ऐसे ही डिस्पैच हो गया, मिशनिंग हो गया। जब ये फिटिंग होने का टाइम में उस सस्पेंशन पैड का उससे वो बराबर फिट नहीं हो सकता है, then ultimately what happens, your casting will get reject and this total time will get failed. And as a quality person, you should
Karthik, we can't hear you. So if you can just connect to your microphone again. Karthik? Prayut, do you have Karthik online?
Yeah, now I guess Karthik is
Hello.
getting connected.
Yeah.
Hello.
Yeah. Yeah.
Can you hear me? Yeah.
I can hear you now.
Destructive testings are like tensile, compression, impact, etc. In this, you are taking the specimen and you will be destroyed the specimen to analyze the material behavior. By the end of the testing, we are destroying the component and it cannot be used further process. And NDT, non-destructive testing. Prayut, can you go for next slide? Yeah. The name itself indicates that non-destructive testing, without destructing your component or product, you are testing the part. There are so many types of non-destructive testings. Some of them are commonly used in our company. Penetrant testing, magnetic particle testing, ultrasonic testing, visual testing, and radiography testing. When it comes for penetrant testing, this method works on capillary action. Penetrant testing can be detect only surface defects that are open to surface. The main important point is PT can be done only for non-porous components. There are two types of testings. In DP testing, there are two types of testings. One is fluorescent and another one is non-fluorescent. Fluorescent is like with UV torch, we have to check after applying the penetrant, and for interpretations you have to check with UV torch, whereas non-fluorescent, which can be done with visible light. And step-by-step procedure for PT: pre-cleaning, penetrant application, dwell time, removal of excess penetrant, and application developers, interpretations, and post-cleaning. When it comes to pre-cleaning, first you have to take the product or test specimen and you have to see the visually, is it free from dust or oil marks or any other contaminants which covers the pores or crack marks on the surface. You can see on the picture, this is the crack filled with dirt. Can you go? Then you have to apply the solvent remover. you'll get 4 products. One is solvent remover, one is penetrant, one is developer, 3. First, you have to apply the solvent remover, you have to clean the product, and you have to leave for 2 minutes, and then you have to apply the penetrant thoroughly. Then you have to give some dwell time based on the component from 12 to 60 minutes. 12. Then after dwell time, you have to clean the product with lint-free cloths. Then after that, you have to apply the developer so that it will, through the capillary action, it will suck the penetrant and it will show on the casting or your component. Next slide. Magnetic particle testing. MPT, it is checked for surface and subsurface defects like cracks, hot tears, inclusions, sand drops, and coal sheds. But it is mainly used for checking cracks, and this can be done from 3 to 4 mm. This method works on the principle of magnetic flux leakage. Normally मैग्नेट में नॉर्थ से साउथ पोल तक हम जब मैग्नेटाइज करता है कंपोनेंट पे तो मैग्नेटिक फ्लक्स विल मूव when you have that leakage there, whatever the iron particles you are spraying on the components, it will go and it will sit there so that you can see where is the crack. There are two types of methods, that one is fluorescent and one is non-fluorescent, which can be seen with visible light. Whereas fluorescent, in the same way, you have torch, you have UV lights. With this, you have to check the component for cracks. The main disadvantage for MPT is it cannot be performed on non-ferrous material, which is non-magnetic. This is the fluorescent magnetic particle inspection picture. When it comes to normal non-fluorescent, only heavy cracks and which can be seen with your naked eye, that can be detected. Whereas in fluorescent, very minute cracks which cannot be seen with your naked eyes, it can be detected and we can see very clear. This is the advantage with fluorescent magnetic particle inspection. Coming to ultrasonic testing. Ultrasonic testing is like ultrasonic. High ultrasounds we are transmitting in a component, and if there is any crack or any flaw or anything, it will reflect back. And in the same way, it is showing in your monitor. Ultrasonic testing is recommended for detecting subsurface defects. Only subsurface defects can be identified in ultrasonic testing. It works on the principle. The main principle of ultrasonic testing is transmission of high ultrasound waves in a component and identifying defects. Here we have a monitor, and this is the pulse receiver and transducer. When you check the component, when you say this is the thickness of the casting, you can see that the sound waves are going and it is touching the bottom of the component and it is reflecting back. When you are moving the transducer towards that crack, you can see that sound waves are going and it is touching the crack and it is reflecting back. There you can see in the monitor, the back wall, if we say that the thickness of component is 50 mm, the first back wall echo comes at 6 mm. Okay, say 6 mm. Where you have a crack, there the crack echo has come at between 2 and 4 mm. This is how the UT works. In this, we have so many techniques, pulse echo method and automatic scanning method. In pulse echo method also we have A scan, B scan, C scan, and we have DGC, DAC curve, distance amplitude curve. This is used for checking at a time for multiple thickness, and DGS is nothing but if you are identifying a defect, if you want to know what is the defect size, that is a DGS. With DGS we can check the defect size. Few equipments have that feasibility, few equipments doesn't have that feasibility. Based on your selection of the hello.
Yeah, we can hear you.
Yeah, based on your machine you can check that. Advantages of NDT testing. What are the advantages of NDT testing? When you don't have NDT testing, you can check the mechanical properties like tensile, impact and all. When you are supplying some parts for defense or aerospace and all, before that NDT, there was destructive testing, like they used to cut the component for every section, and they used to mill and they used to see and they used to develop in that way. But now we have NDT. We can check the components with ultrasound, radiography, and we can see the shrinkages and other defects to avoid the failures and save the human lives, and to reduce the manufacturing and development cost, and to give the information about defect and criteria. Prayut, next slide. What will make working in Foundry more joyful and pride? In Foundry, learning is never-ending process. Every day it will come up with new challenges. So until your death, you can serve and you can learn new things. आज एक प्रॉब्लम आए तो सॉल्व कर दिया, फिर नेक्स्ट डे स्मूथ से जाएगा बोल के गारंटी नहीं है. हर डे एक एक प्रॉब्लम आता है, कंटिन्यूअसली हमको वर्क करना ही पड़ता है. हम and we foundrymen can be pride that we are the base of any manufacturing process. We are supplying our products in every sectors like defense, aerospace, navy, automobile, heavy engineering and construction, health, material handling, whatnot. Everywhere our products are there. Even after retirement also, you can work as an advisor or auditor or visiting consultant.